In Module 2, Section 6, we will discuss three properties of real numbers: the associative property, the commutative property, and the distributive property. Now, some of these properties you will be familiar with even if you didn't know their names. Let's start by defining the commutative property. The commutative property says that when we have addition, it doesn't matter the order in which we add the numbers. You can add the first number plus the second number, or the second number plus the first number. For example, 2 plus 3 is the same thing as 3 plus 2. And we know that to be true. 2 plus 3 equals 5, 3 plus 2 equals 5. The same is true for multiplication. When we multiply two numbers, it does not matter the order in which we multiply. The associative property tells us that when we are adding three numbers, it doesn't matter if we add the first two numbers and then the third number, or the second and third number and then the first number. Since we have the same operation, and that operation is addition, we can add in whatever order we choose. The same is true for multiplication. We can multiply the first two numbers together and then the third number, or the second and third number and then the first number. Now, this associative property is only true for addition and multiplication. It cannot apply to subtraction or division. There are certain circumstances where you would get the same answer anyway, but that would be a coincidence. It is not a fast rule for every subtraction or division statement. Let's just try a few examples of the commutative and associative properties and simplify the statements. So if we have x plus 8, here we have two terms, so the commutative property would be appropriate. And x plus 8 will be the same thing as 8 plus x. Remember, with addition or multiplication, the order is irrelevant. For example B, 7 times x is the exact same as x times 7. Now, in examples C, D, and E, we have more than two terms, or more than two numbers, values. And so we're going to use the associative property for these last three examples. 3 plus 8 plus 1 is the exact same thing as rearranging the parentheses and first adding 3 and 8, and then adding 1. If we wanted to simplify this expression, starting with the original, let's rewrite the original. 3 plus 8 plus 1. We know using order of operations, we work the parentheses first. 8 plus 1 is 9. And 3 plus 9 would be 12. Well, we can see that by moving the parentheses, we would then add 3 and 8 together first. 3 plus 8 is 11, but 11 plus 1 is also 12. So the placement of the parentheses, because we have addition, is irrelevant. The same is true for examples D and E. I'm not going to simplify each of these examples, but I will move the parentheses to show how the associative property works. Instead of negative 5 times 4, inside of parentheses, let's write negative 5 times, and then inside parentheses, we'll have 4 times 2. Actually, that is an example of the associative property. And on example E, what we don't see is that x and y beside one another is multiplication. We just don't see the multiplication symbol. So first, let's rewrite the original as x times y, in parentheses, times 18. And now, using the associative property, we can write x times, and then in parentheses, we have y times 18. And because we have multiplication all the way through the problem, it's okay to change the order in which different terms are being multiplied. Different factors are being multiplied. The last property that we're going to see in this section is the distributive property. And unlike the commutative property and the associative property, the distributive property is one that you may be familiar with, but isn't going to jump out naturally in most problems. And for that reason, we're actually going to use the distributive property more times, at least we will realize we're using the distributive property more times than the associative or commutative properties. So this is the distributive property of multiplication over addition. And that tells us if we have a number A times the sum, B plus C, That is the same as A times B plus A times C. A few more terms that need to be mentioned before we move forward are identities. We say that 0 is the identity element for addition, because when we add 0 to any number, it does not change the number. So 0 plus A or A plus 0 is still A. And 1 is the identity element for multiplication. A times 1, when we multiply by 1, it doesn't change the result. 1 times A, again, it does not change the original value. So let's use the distributive property to write each expression without parentheses. And then we're going to simplify the result. And so what I like to do is take the number on the outside that is being multiplied into the set of parentheses and draw arrows so that we know where that number is going. Following each of our arrows, we're going to multiply. In the first arrow, we have 7 times x. We write our addition symbol, plus 7 times 4y. To simplify, 7 times x, we don't write the multiplication operation because 7x right beside one another, it is understood that we are multiplying those two factors. Plus, we want to multiply 7 times 4, and remember, that's okay. We can do that because of the associative property. It doesn't matter what order we multiply. 7 times 4 is 28. We're also multiplying the y, although we don't have to write the multiplication symbol. So 7 times the sum of x plus 4y is 7x plus 28y. And that's how we use the distributive property. Let's try a few more examples. Now we have 3 times the sum of negative 5 plus 9z. Again, I draw my arrows so that I know where the 3 is going, where it's being multiplied. So I start with 3 times negative 5 plus 3 times 9z. When we simplify each product, we start with 3 times negative 5, and that would be negative 15, plus 3 times 9z. It doesn't matter that the 9z is in parentheses. Using that associative property, we can multiply the 3 and 9 together first. 3 times 9 is 27, times z. We just put the z at the end. We do not need the operation for multiplication to be present. So negative 15 plus 27z will be the result, the simplified result. Now in the last example, we have a negative sign outside of a set of parentheses. That negative sign can be rewritten as a negative 1, and that's what we're going to do first. Negative 1 times 8 plus x minus w. Now we distribute the negative 1 to all 3 pieces. That shows us where the negative 1 will be multiplied. So we start with negative 1 times 8 plus negative 1 times x plus negative 1 times negative w. Multiplying each set of factors, we start with negative 1 times 8, which equals negative 8. Negative 1 times x is negative x. So instead of writing plus negative x, plus a negative is the same thing as minus, so minus x. Negative 1 times negative w is a positive w, so we'll write plus w. Let's try another example. Let's use the distributive property to write each expression without parentheses and simplify the result. So the number that is being multiplied into the set of parentheses is 1/2. I'm going to draw arrows from 1/2 to each term inside parentheses. Now notice that 1/2 does not multiply to the 1/2 at the end of the expression. That is because the parentheses end. Wherever the parentheses end, our multiplication ends as well. So let's write our new factors, our new products. We have 1/2 times 8x plus 1/2 times 7 plus, we bring down the 1/2. Now we need to simplify each of our products. In order to do that, I have 1/2 times 8, a whole number. Let's change 8 to a fraction. We can do that by writing 8 over 1. When we multiply fractions, we multiply the numbers in the numerators, the numbers in the denominators. 1 times 8 is 8. 2 times 1 is 2. We also have times x. I'll just write x at the end. If I wanted to write it on top or bottom, it would have to go in the numerator. Instead of doing either of those, I'll write it at the end of the fraction. Plus, we need to change the second whole number, 7, to a fraction so that we can multiply. So we multiply the numerators, we get 7. Multiply the denominators, we get 2. And again, we bring down our plus 1/2. Now, before I combine like terms, I am going to simplify my first fraction, 8 over 2, or 8 divided by 2. 8 divided by 2 is 4. So it becomes 4x plus 7/2 plus 1/2. Now we notice that the first term has an x. The second term does not have an x. The third term does not have an x. So we cannot combine through addition a quantity that has x and a quantity that does not have x. It'd be like saying 4 apples plus 2 oranges equals 6 apples. We can't do that. So because 4x is the only term that has a variable, it's going to stand alone by itself. Now 7 over 2 and 1 over 2 are both numbers. They do not have a variable. So we can add 7 over 2 and 1 over 2. They already have a common denominator. So we write 2 as the denominator. 7 plus 1 is 8. Now just like before, we want to reduce that fraction. 8 over 2 is 4. 8 divided by 2 is 4. So putting all of this back together, we had a 4x plus the simplified sum of 7 over 2 and 1 over 2 is 4. So the answer is 4x plus 4.